this work? Can everybody hear me? All right, cool.
2 minutes. Should we do everything faster? Is this talk about 5 minutes?
We'll see.
So I'd like to start today's last session, session 4. The title is Release Faster by David Kramer. Please.
Thank you. So my name is David Kramer. I assume some of you know me. I'm going to talk about releasing faster. So about a couple months ago, I joined Dropbox. Everybody knows what Dropbox is. I work on developer productivity there, which doesn't really mean too much. But specifically, I work on things like our testing infrastructure, code workflow, anything that really improves the other engineers' lives at Dropbox. I've also built Sentry, which is actually a good example of a developer productivity tool. But today, I'm going to talk about how to release faster. So we'll start by defining what that actually means. There's a kind of a common thing going around called continuous deployment. It's become something more interesting over the last few years. Things like Heroku, there was just a talk on OpenShift, OpenStack. All of these things are kind of promoting this idea as well. So a very simple, dumb way might be, we're going to have a cron job that updates our site, every 5 minutes. This is definitely not what we're talking about today. The important bit is that we're going to ship code as soon as it's ready. We're going to release it when we want to. So the general workflow looks kind of like this. You're going to create a commit. Maybe you have a code review process, integration, which is like your test server Jenkins or something along those lines. If it fails, you're going to repeat this cycle. If it doesn't, then you can choose to release that code at that point. You're going to have some reporting and then like some decision making after all is said and done. So there's a few things I want to talk about with this. And these are kind of like the big picture items I think that it takes to actually get very quick releases in. And the first one is like simplified development. So like I said, I joined Dropbox 2 months ago, and this was kind of the first thing I hit. You go through like a few-week boot camp at Dropbox, and one of the first things you do as an engineer is set up a virtual machine. So the virtual machine instructions are basically like, it's this long wiki page. It says, open VMware, click new, run some scripts, copy in an SSH key. It was all very manual, right? And my face was immediately like, what? Like Dropbox has 150 engineers, and nobody had really solved this problem, right? And I instantly reacted like, why don't we just use Vagrant? Is everybody familiar with Vagrant? It's a tool that scripts virtual machines. Anyways, a lot of people at Dropbox were not familiar with that. So the first thing I did, instead of doing what I was supposed to do, was optimize kind of this process. And that started with fixing our bootstrap. So not only did I have to manually create the VM, but as soon as you created the VM, you basically sat there for like 30 minutes while it was doing a bunch of work. And this is actually really important. So this bootstrap process, like it affected me as a new hire, right? Like it's my first impression of what's going on. I'm sitting here, I'm wasting a day, and it's not fun. And you might say, well, you're only hired once and the bootstrap only matters once, but that's not true. Like I've had to rebuild my VM probably 20, 30 times at this point. And like we're optimizing like everyday use when we start optimizing that bootstrap. And more importantly, and one of the big things I'm going to talk about today, is it affects the time to run your tests, because you should be able to bootstrap your test environment the same way that you bootstrap your development environment. So again, I mentioned Vagrant. We actually just switched, or we're switching to Vagrant internally at Dropbox for all development and potentially some testing. And it's very simple. Vagrant basically it'll control something like VMware, which is what we use, or something free like VirtualBox, and it will allow you to specify some various steps. And specifically in ours, like we're just saying we need to run this provision script. And in the end, that script actually reaches out and it says, okay, we're going to apply Puppet configuration, or we're going to upload some credentials or whatever. But the important thing is it's run the single command, and it's very intuitive. Like, it just works at that point. And even better is, like, now I can just rebuild the VM by running a destroy command and running this again, and I'm back exactly in the same state that I was before. So part of this, the bootstrap, this is great, but it still took like 20, 30 minutes for this to actually execute. And while we haven't quite solved this yet, I spent a lot of time at Discuss solving these kinds of things. And the first step is always removing dependencies. The more stuff you have to deal with in development, the harder your job is going to be. And more importantly, you're never going to reproduce production, so really having all this in dev doesn't matter. And this is kind of like this age-old argument for, like, we need to kind of mimic production because otherwise when we write code, it's not going to work. It's very rare that you write code in development, even if you're not using the same stack, that it actually causes a real problem in production. So just simply stop trying is my advice. We'll see if Dropbox accepts this, but it's kind of the direction we're going for. And I mean, if you think about it, like, we're going to talk about web stacks a lot in this. So do you need Apache? Well, Python has a lot of really simple web servers. Like, you can install Unicorn. If you're using Django, it has one built in. Flask has WorkZig built in. So you can just run those. And you really don't need Apache. Do you need HA proxy? Unless you have a really good argument, the answer is definitely no. Like, HA proxy is for load balancing and routing. Like, your web server is already going to solve that for you, and you don't need to test HA proxy. Do you need RabbitMQ? If you use Celery, like, you can get around this by just writing to the database or writing to Redis, which are much easier to configure. Zookeeper, another kind of common dependency in production, doesn't matter at all in development. Hadoop, this one's kind of fun because it causes us a lot of problems. And just, like, really think about it. Like, what do you actually need in development to write code that's actually going to work? Like, in my opinion, most things you need a database and you need a web server, and your web server is already built in, right? So that's very simple. And more importantly, we can utilize build servers to actually test these dependencies. So, like, if you really don't think Zookeeper is going to work, and for whatever reason you think you have to test it, do it on a machine that can have, like, 64 gigs of memory versus, my maxed out MacBook, which can only have 16. But specifically, like, you're going to have to find your own bottlenecks here. So, like, ours, like, the VM is a big deal, but when I was at Discuss, I was a huge proponent of not using a VM. Like, Discuss, we eventually got it to a point where we had a makefile, which was really just a shortcut for pip install the requirements. But it was like you did brew install. Homebrew for non-Mac users is apt, basically, to some extent. So you could brew install Postgres, brew install Redis, and then you'd run make inside of a virtual env, and you had Discuss fully up and running in a compatible enough version that you would basically never create issues in production. And now this may not scale when you have 150 engineers like Dropbox or your Facebook or Google, but, like, if you're a small company, none of this matters. So, like, identifying what's actually problematic for you, and it's going to be the thing that actually frustrates you whenever you have to do it, is a pretty big deal. So the second thing I want to talk about is testing. And this is kind of the big one, right? Like, everything else I'm going to talk about today doesn't really matter. As long as you can get testing down, like, you can release as often as you want. And this is actually the biggest challenge. So I joined Discuss, about 3.5 to 4 years ago. And, like, testing was it wasn't really a thing there. And I hadn't really done a lot of testing. But eventually, like, we got that into the system, and, like, everybody was writing tests, and Discuss basically on the back end didn't really break anymore. And that was, like, a huge achievement for me. But the biggest difficulty we had was convincing, like, random guy over here that writing tests is a good thing. Like, we all know it's good, but we don't want to spend time doing it. So, like, kind of the solutions that I've come up with to these problems are always, like, built around tools, right? So the first was making testing easier. And there's numbers of ways that you can do this. And this kind of depends on your own case. But, like, the way I always look at it is if you have a project and say you're just fixing a bug in a piece of code. And you can go in and you can fix that bug and you can easily find the tests. And then you can see the tests and actually understand what they're testing. I'm sure we all have, like, legacy code where there's, like, some test case which is doing everything that you could possibly imagine and then running, like, 20 assertions. And you have no idea what it's actually testing in the end. So, like, the quick sanity check here is, like, if you can look at a test, understand it, and maybe copy-paste that test to where you change a line, and I'm saying you change a line and maybe there's only, like, 3 lines total, and actually know what's going on and have a very quick passing test, like, that's a success. That makes testing very accessible, and it makes people want to write tests. So a lot of this is actually also around, like, building better tools, right? Like, one thing we focused on a lot at Discuss was trying to optimize our test workflows, right? So we basically switched test runners, I think 3 times. We started with, I think, unit test, and then, or no, actually we started with Django stuff, which does not cater to a lot of these ideas. And then eventually we switched to Nose, and then some projects after that we switched to PyTest. And like Nose and PyTest, phenomenal test runners. And on top of this, we built a bunch of like additional utilities to perform various other things we needed to do. So like I said, PyTest is an amazing library. Flake 8, super useful. It's basically a combination between PyFlakes, which is a static linter, and PEP 8. And mock is also another one of my personal favorites. There was a pretty good talk earlier, if you missed it, that I would definitely check out the slides, because it goes through a lot of the use cases of mock. But your main goal with all of this, no matter what the tooling is, to make it more accessible. Like, you want me to want to write tests, right? So part of that, like, if you can make it accessible, like, you're going to want to actually run the tests. So this is kind of a challenge, and this is a challenge we're facing at Dropbox right now as well. So there's 2 things. Like, a lot of these build systems are not going to test what you want to test. For us, like, we want to test every single change. If you have Jenkins or you have something else, there's a good chance that you're using Git or Mercurial, and you're going to test like an entire set of changes. And that isn't really useful to us, because we want to have we want to know that every little change is stable, because every little change we can make like an individual release out of. So what we've done in the past, Sentry and Discuss both use Jenkins, and Discuss has a very complex layer on top of Jenkins, so it's very atypical. Sentry is literally just setting it up, and I encourage you, if you don't have an integration system, to look at this. When I joined Dropbox, we were using something called Bitten. Does anybody know what that is? Because I had no idea what it was. And I guess it's some kind of build system built into Track, which I was also surprised people were still using so heavily, that uses XML configuration to do basically what Jenkins does. So anyways, you get an integration server set up, and it's going to, maybe you've gotten it to run every commit. It's going to run your tests every commit. It's going to report to people through whatever mechanism works for you. And so now you have some level of continuous testing, right? Well, that's kind of okay. Like, you commit something and you know if it was good or bad, right? So that's okay. But wouldn't it be better if like we could test before we committed? And now there's the issue with like tests are slow. Like, if your tests do anything, they're going to be slow eventually. So we actually optimized around this in 2 cases. Like, we did a lot of static analysis locally, like PyFlake's crazy fast. And we did like kind of some smart, dumb test detection. So if you changed foo.py, we'd run tests in like test foo.py automatically whenever you'd upload a patch. And it just made it like a really quick sanity check that didn't take a lot of time, so it was very accessible. And it gave you like a 90% level of accuracy, right? Like some region that was actually very acceptable. We also test during code review. So code review is a big thing I'll talk about in a little bit that we adopted. And like, so it generally consists like upload a patch, somebody's like, oh yeah, this looks good, and then you merge it in, right? It's just like pull requests on GitHub, except inverted a little bit. So the nice thing here is like we did a few tests like before you uploaded the commit, but now we can run asynchronously the entire test suite and report back hopefully before you actually have had the patch reviewed. So you know if it's actually going to be good to merge in. And then finally, we actually have to test another phase here. Maybe like while you were going through review, there's been like 10 other changes. So we actually need to apply that patch, like rebase that patch on top of like the tip now, and we need to test that again just to make sure everything's still stable. But again, once you have something like Jenkins, this is just firing off triggers and like spending CPU on it, right? And then this is probably the most time I spent on tests was optimizing execution time. When I joined Discuss, it took about 40 to 60 minutes, depending on which time period you look at, to run our test suite, which means like you're making a change, and then an hour later, like, oh yeah, that was broken. Maybe you remember what was going on. Like, I probably don't. I've probably moved on to something else. Like, in the end, we got it down to, I think, 3 or 4 minutes, which to me was a really good target. Dropbox is in a similar realm where it's like 20, 30 minutes for us, and we're setting the like hard goal that it has to be 5 minutes or less to get a response from the build servers. As an example, like Sentry, it's 20 seconds to get a response. Like, I make a change, it'll go through here, it'll pass tests, it'll deploy in a few minutes. So it's like 5 minutes to get a change live. And I still have like the context to know exactly what was going on. So if anything actually happened here, I'd be like, oh yeah, I just changed that code. Like, I recognize what's going on. And the main thing is like a very, very tight feedback loop. Like I said, our goal is 5 minutes. Like ideally, you could get a response in 30 seconds because the faster you can get that feedback loop going, the faster you can iterate, which again means you can like release more often. And part of this is actually like preventing mistakes. And this is even more important as you grow the team out. Like depending on the size of company you work at, you've probably dealt with a problem where like somebody broke the build and you're all running like out of master. So now like you can't actually do anything because like master is broken. Or maybe it's like you've committed on top of a broken patch that's in master and now the build server's yelling at you because things are broken. So this is a big deal. So like the simple thing is like don't deploy broken builds, right? Like it's very easy. Like Jenkins is saying, oh, that one was broken, that one was broken. Yeah, we're not gonna deploy those. But the better way is to not merge those. And depending on what system that is, like if you use GitHub, for example, Travis CI will tell you when a pull request fails. So now you can be like, oh yeah, I'm not going to merge in this pull request because it's broken. And now nobody building out of master is blocked on that because they never had to deal with the breaking changes. So part of that merging is like where the code review process comes in. So a lot of people talk about code review being a time sink. And I'm going to strongly disagree that code review actually saves you a lot of time. And more importantly, it has to be mandatory. If you say, yeah, we can make an exception, like some things can go outside of code review, like nobody's going to use it. We maybe got 50% of Discuss like heavily on board with code review and everything. Dropbox is probably less than that. And it's definitely harder in larger organizations to adopt processes, which is why like when I say mandatory, like tooling has to make it mandatory, like ACLs to make it so like you cannot just commit code. And this is actually a really big deal because you can build so much tooling around the code review. Like you can run the tests asynchronously like I was talking about, and if you don't go through code review, you've now lost all of those sanity checks. For this, we use a tool called Fabricator. There's a few others out there like ReviewBoard and Garrett. Strongly recommend this if you're going to pick up code review. This is the best tool you will possibly use. It was released by Facebook about going on 2 years, I guess. It's very actively developed by a couple guys who are no longer at Facebook, and it's very, very powerful. And the simple concept is that I'm making I'm going to speak in Git terms because it's easier. I'm going to have a feature branch, and we're going to call it like whatever, I don't know what it's doing, but it's just my patch to change something, right? We're going to commit code in that feature branch, and this actually has a CLI. So you can say, like, I need to upload this patch. And it's very heavily integrated with Git. So it's not like a complex CLI. You just say, like, submit review, basically. It'll upload that diff. You can go in here, leave feedback, whatever. But eventually, you're looking for a pass or fail, right? If it's a fail, it's just like that commit cycle. It goes back in the loop. And if it's a pass, it's basically giving you permission to land this change. And again, all the tooling's built out. So it just comes down to now you run one more command. It deals with all the Git magic or Mercurial magic or whatever, and it will just like apply that patch on top of a rebased master. And so now if you've gone through this and you have like, you can actually see up here, it has some integration with various things. So like this one, we know that it ran the linters and like everything was okay. They don't have any unit tests running here, but you get the idea that it actually will integrate with your systems fairly well. And it gives a lot of insight to the reviewer because the reviewer's job should not be to run your code or to test your code. They should be able to say, like, is that code sane? Like, does it make sense? Are you taking the right approach to this? And this is actually a big deal. So, like, I talked about, like, tooling and culture. This is one of the best tools you can have to influence culture. Like, as soon as you have code review, you can now say, hey, you didn't add tests for this. Ideally, you automatically say, hey, there's no tests for this, so you can't commit that. But that's like, that's a little bit scary because at that point it's like, well, how do we deploy this thing that's critical? Anyways, very, very easily to influence culture once you have mandatory code review in place. Also really useful is it helps you educate developers. Like you don't need pair programming, you don't need somebody to sit down and help you with every little thing throughout the day for your first couple months at a job. Like you submit a patch, maybe you start working on something else, like somebody's gonna give you a bunch of feedback on that patch. They're gonna suggest like, this is how we style code, or add tests over here, whatever it is, right? Like it's going to help you with the education. And most importantly, this will make it faster to release stuff. Like this is the big argument that's always controversial, and it's like, oh, I don't want to do code review because it's going to slow me down. But it's not going to slow you down if you look at it. It's like I have my feature over here. Maybe it's a good idea. Maybe I'm a perfect programmer and I've designed this feature perfectly, and it's never going to need change. Then I'm set. But that's never the case. And so what it comes down to is like, you're going to make a change. It's probably like 90% there. And then, if you're not going through code review, you're going to probably release that. And then it's like, oh, we should have like changed this, or oh, why'd you do this, or oh, you caused this bug that you didn't know about. And now you just have to you had to wait for that response. And then you're going to have to go back and you're going to have to fix it again. And like, you're going to have to consistently context switch, which is a pretty big deal. So in the end, like, you skip a lot of that by just going through code review and getting a second set of eyes on that. And this is like the most important. Is like, I talked about that sanity check. And this is really big, or really important for large organizations. Like, Dropbox has a ridiculous amount of code in this monolithic repo. And I had no idea what was going on when I started changing stuff. But somebody else did. So I can assign some reviewers, and it's like, oh, hey, this is actually going to break this. I'm like, I didn't even know that existed. Like, that's a thing, right? So this is super valuable to catch a lot of this. It's a very manual process, but the tooling is very strong around it. And the big thing is you're trying to aim for quality patches. So if everything's going through code review, if it's running tests and everything while it's in code review, and it's basically everything's given it the thumbs up when you're ready to merge it in, it now means that your master branch is actually always stable. It means your master is always your release, and you don't have to deal with any of this git flow type stuff, whatever. You just know that master is always what's going to be production ready. And that's actually a really big deal, and it simplifies a lot of processes. So, once you're kind of in this realm of things, say you've got code review and all this, you can commit, it's going to be good, master's always going to be great, right? There's a big problem. It's now that we're pushing things out more rapidly, and we need to kind of control that. And we can do this through something called feature gates. So this is a concept that I think Yahoo was one of the first people to really talk about it and publicize it. And at some point I read the article and I'm like, oh my God, this is amazing. So we started building it. But the idea is that you can basically have a branch of code and you can say, I want this group of users to run this code and this other group of users to run this other version of the code. Specifically, you can be like, all right, I want 1% of my users to have this new feature that may or may not work right. Or I want to roll out a feature slowly that maybe like backfills data. And I can say 1% of the users are going to start backfilling their own data or something. And then you can slowly ramp it up, or you can use it to say, like, I want only Dropbox to be able to access this new feature. And that's actually something we do all the time. And like Facebook is huge into this as well. And it's a lot of like, let it sit and like soak for a little while with your internal audience, which is more than enough. And it's very important because when you release it to like, say we're all developers and we're releasing a tool to just ourselves, like we're going to be more willing to give useful feedback and accurate bug reports than say like my parents who barely know how to work a computer. So if I'm releasing it to them, it's like, oh, I'm just going to ruin their experience. And like, if it's Dropbox and I ruin their experience, they're going to go use something like Google Drive or something we don't want to happen, right? So this is really important. We actually have a really long incubation cycle on some things. And it was actually really interesting because we use this at Discuss to do like week-long cycles. And there are like 6-month-long cycles for certain features at Dropbox. So it's like, you can use this very powerfully to just slowly iterate on ideas and then actually push them mainstream as soon as they're ready. And like I said, it's mostly to limit the scope of what you're doing. So if you're making a lot of changes, you could also say like, I'm not sure if this is going to work really well. There could be a lot of edge cases. I can just put this behind this like gate and just say turn it off, right? If you use Django, we built something at Discuss called Gargoyle, which may not work on Django 1.5, I'm not sure. But it's basically everything I just talked about. It's very, very easy to use. It's pretty powerful and pretty optimized. And it just implements this for you. It looks a little bit something like this. You just call out to this Gargoyle object. You say, is this feature active? The feature name is awesome here. And then there's a little bit of magic/logic that happens. We're passing the request in here, which a Django request has a bunch of attributes bound to it. Generally, one of those is like a user. So we're actually able to introspect and be like, oh, you passed in a request. We know a user is attached to this. Is it active for that user? But the cool thing about Gargoyle is we made it really extendable. So you could actually, you can pass in n objects here. And you could say like, is it active for this website? In Discuss's case, a website was like a database object. So we'd pass that in here, and we'd have a switch that says, is it active for CNN.com? And things like that. But in the end, like, you could implement this very simply. Like, this could be a memcache call. If, cache.get my key name, then I'm going to return this to the user, if you just literally want an on-off switch. So if you've gone through all this trouble, like, this is probably the most critical for like keeping quality high and slowly iterating on ideas. But once you've done that, like, you can actually start looking at the automation part, right? So Heroku is actually a pretty good example of this. Heroku is very simple in the sense that you simply create an app similar to everything else that's a platform as a service, and then you push to a remote in this case. So it's like, I'm going to make my change, I'm going to commit it, I'm going to push it. This is kind of good and bad, right? Like, because now all of a sudden it's like super easy to push changes, and they're going to go live really quickly, so you can just like, oh yeah, if I break it, I'll fix it right away, which not really ideal. Like, I'm definitely a culprit of doing this all the time on Sentry, just like, oh, I'm going to commit all this. You know, maybe it's after I've had a few drinks and I'm hitting the Ballmer's peak, and I'm getting a ton of stuff done, and I'm like, I really just want to push this live, and then it like breaks. But so it's good in the sense that I was able to really fix it fast, but it's also bad in the sense that it enables you to create problems. So we take that idea and we go back to our original thought. Like, it's not about deploying everything. It's about deploying when things are ready, right? But Heroku still enables that. All you have to do is push to the Git remote, and then you can deploy it. And it doesn't have to be every commit. Like, what I've noticed, and I'm a strong believer in deploying every little change. Discuss eventually, we just said, you know, whatever, we're going to deploy like once a day. It's good enough. Dropbox, they deploy once a day except for like various things. And it's kind of acceptable, right? And I would say it's still practicing continuous deployment, because like if you look at desktop software with their crazy release cycles, or like ancient artifacts where 1980s where everything's really, really slow, like if you can deploy every day, that's a big deal. If you can deploy every week, that's a big deal, right? So it doesn't matter like how often you're doing it or if you're doing every single thing. Just being able to do it is very important. Yeah. So, you know, again, if we take a look at the original workflow, like deploy is kind of arbitrary now. Like, we don't have to deploy. We just want a release to be ready, right? So that deploy phase could be spread out because it's now just like a release phase. So it could be like, we're going to have a staging environment. And staging could be, it could actually be production. So we could have deployed it, and we could use feature gating, and we're going to be like, oh yeah, Dropbox sees everything for 6 months or a week or whatever before it goes live. And that's our like release cycle, our stage cycle. And then we can choose to just like flip that switch or do whatever process right to release it. Discuss, we had this thing where basically the stage part was when it was in, or when it passed tests in code review, we would be able to push it immediately to the staging server, which nobody ever really used. But you could do a sanity check if you did want to on that staging server. So, you know, the cycle doesn't really matter here. It's just like we can release it whenever, and we can determine how long that phase is. And that just comes down to like QA, right? So, how am I doing on time? I wanted to end this with a few kind of big ideas, or maybe not so big. The first one is quality over quantity. This is a very hard thing to practice. I'm terrible at it. A feature or an idea should be like a single change. Generally, that's not what happens, and you end up with a bunch of changes. But if you can slim that down, you can keep small features, and you can do really quality changes, you're going to end up at the same place. You're just not going to have to backtrack a bunch along the way. And this is kind of what a lot of this pushes. Like, better testing is going to be higher quality commits. You know, code review is going to be higher quality commits. And the whole idea is that you can get this quality and improve quantity. So like, the idea is that you're setting your bar for quality up here and you're not moving it ever. And the quantity is just coming like as you increase your tooling and you build better tooling. And a lot of this comes down to like, how do you scale that out? So like, so it was really interesting. You know, I joined Dropbox, and the stuff I did at Discuss 3.5 years ago, and Discuss is 50 people. It's maybe like 15 or 20 engineers, somewhere in that realm. All the stuff we built, I look back on, and I'm like, that was really good. You know, after I left, like, quality was really high. We had all this really cool tooling. And I realized this after I joined Dropbox, and I'm like, they don't have any of this tooling. Like, this is really interesting to me. Like, why didn't somebody build all of this, like, over the course of those years? So now I'm kind of, like, redoing all that. But it's interesting because, like, the same ideas are kind of applying directly. And that's, like, my next thought is your problems are not unique. Like, the exact same things that I implemented at Discuss apply cleanly to Dropbox. And Dropbox is 150 engineers. It's going on 500 employees. And it's identical problems, identical solutions. These same things are also not quite exactly applied, but very similarly applied to Sentry, which is like me and one other guy. It's like Sentry goes through a build process, takes 20 seconds. Sure, it's not the 20 minutes or whatever Dropbox has. And then it's immediately deployed. But it's like that same technology basically influences what we do elsewhere. And that same technology has enabled my partner on the project, and he's a designer who's terrible at code, to basically commit and release whenever he needs to. And he's actually pretty good at not breaking stuff, like after we implemented a little bit of this tooling. So with that, I just wanted to say thank you guys for having me. Tokyo has been awesome so far. Hopefully I'll find more ramen before I leave. And I'll open it for questions.
Do you have any specific recommendations for a good feature review process? I mean, a code review process?
Oh, yeah. I should have included that. What it looks like for us is, and this is something that I'm working on the low-hanging fruit at Dropbox right now, but we tried to tackle this and we tried to build better processes around this at Discuss. And our idea was basically you submit a code review and there should be a fairly quick turnaround. So we wanted to enforce like a window where the reviewers are blocked. So I submit a code review, I'm now blocked, right? I'm waiting on you to review it. So like the idea was that within a few hours of collective review time, like you should be able to land a change. And that means like, if I'm waiting on you, it's blocked, and like that's the only time we care about. If it's back on me, I'm probably doing something else and it's completely okay. So what we said is like, we started with getting really good tooling, and like Fabricator was amazing for that. It really made it accessible to people. And then it was like, okay, you upload a review, like it has a single reviewer acceptance policy and you can't change that. So we said that like assign it to between 2 to 4 people who are directly related to whatever you're changing, like ideally a component. The lesser the better here, so like 2 or 3 is ideal. One person accepts, and then you can land it. And we didn't have the tooling all the way there, because again, we were 15 engineers and it wasn't as big of a deal. But for Dropbox, we're gonna like definitely enforce more things, and it's gonna be like, all right, it's been accepted. Now you can suggest it be landed, so some system's gonna merge it in from like a queue and things. So it's like, depending on your scale, I think is when you tweak the process. But the biggest challenge that I've seen, and the thing that we're still working out what the best practices are, is like, how long are things allowed to sit in code review, and how do we make sure people are not ignoring them? Because like I have changes that have taken like several days at Dropbox to get out of review, and it's just like, there's not a lot of good practice in making sure it's done or tooling to enforce that it's done. So that's definitely a challenge, but otherwise like the process is pretty straightforward.
So a related question would be how much time do you spend reviewing code instead of writing code?
Usually not too much, because you're only reviewing like the ideas of it and like general skimming, right? Like you should not be testing it, et cetera. That's the author's job or the machine's job, right? So the way we kind of dealt with that is like we said in the morning, you know, or at least like this was the ideology. In the morning, do code review. You know, after you have lunch, do code review. Before the end of the day, do code review. So at least there's like, try to break it up when you're not context switching. So it's like, this is a very clean time to just like change over and start doing this work. It's honestly not a lot of time. Like, if you understand the code that's happening, like if you understand what the review is being submitted for, like the piece of code or the idea that they have, it should be very, very fast. That's not always the case, because there's generally confusion as you grow, like who's the owner of a project, who should I assign to review this, and you're like, for me, I was assigning reviews to like random people on the infrastructure team, assuming they had any idea what was going on, and it was constantly like, you know, shrugging shoulders, and I'd have to find somebody else. So there's definitely that challenge, but it's easier if you adopt it as a smaller company. Any other questions?
So how often do you merge your development branch into merge branch? It sounds like as soon as develop branch becomes stable, but if you have other indicators.
Yeah, so extending that code review process, right? It's like you have this feature branch. It's a single idea, a single commit. That's not necessarily true, but eventually it becomes a single commit when it's merged. Like we squash everything. And Fabricator actually makes it easy to enforce that as well. It'll just squash for you. So the idea is that like you land it immediately, and as soon as it's gone through the build process, you could land it immediately. That doesn't have to be true. Like Facebook has a different kind of thing where they will like cherry pick and changes, and they have like this roll call to say like, we're going to deploy your stuff. You have to be around, you know, because otherwise who's going to deal with the problem, right? So like it depends on, I guess, how your organization is set up. But the idea is that like as soon as it's green, like you should be able to land that. And especially if you're a smaller company, there's no reason to not push that release out the door immediately. That just changes like as you grow, I think. It has to be a little bit slower for more like sanity checks.
Thank you.
Any other example for feature gate though, other than that you introduced?
There's some Ruby stuff. I don't know much that's open source, to be honest. I think GitHub might have open sourced theirs, but it's probably Ruby as well. There's a version 2 of Gargoyle. I think it's called Gutter. I don't know if it works. They were working on it at Discuss when I was leaving. It isn't bound to Django, which is kind of nice. It's still based on the same principles that things sort of live in this really fast memcache local memory buffer. But if you want reading material, like the Facebook release process is really good. The really simple, but the Yahoo original article on their feature flippers, which is another name for it. There's so many names for this thing. There's gates, there's flippers, there's switches. You start searching those, you'll find a bunch of stuff. But there's not a lot of tooling out there that I've seen, in the Python world especially. But yeah.
You're saying that if you are the Rubyist, we have many tools we can use.
That might be true. But they might not be as good.
Do you have any culture or practice around designing stage or documentation?
Designing, do you mean like
I mean, the
like
architecture
product
design.
concept ideas?
Yeah, architecture design or feature designs.
So, I mean, not really. Like a lot of this was like we decided to discuss as we were trying to not have this constant back and forth that like we would split everything up. And this is kind of where the service-oriented architecture comes in. Like if I can be responsible for the API and 100% of the API, or my team or whatever, and this guy wants to build something on top of the API, he can kind of come up with like his feature requirement, which is kind of like a design phase, right? And then he can send that to me and I can be like, yeah, that looks good. And I'm not talking like crazy specs or anything. I'm just talking like really simple high level, like I need an endpoint that gives me this. But maybe it's more complicated. So I need an endpoint that does this really complicated procedure. And I'm like, okay, what if we do like X, Y, and Z, send that back. And then eventually like that helped us like get through the design flows a lot easier because we like agreed on a direction of something. And then we could do this really rapid iteration after that. So it was like this thing that was kind of like very passive at first, where we would just send things back and forth and it wouldn't happen very fast. But as soon as like we locked down like how we wanted to move forward, then it just like switched into this and it was like, you know, commit, you know, go through the code review process, iterate very quickly on that, and then get it out the door.
Do you create or manage some documentation around the design process?
The communication around it?
Yeah.
We didn't do anything, but it wasn't a problem at Discuss. It was basically just like email Google Docs around and
I see.
and hopefully there's some idea that this should be done at some point, like some roadmap milestone type things. But we didn't have a lot of process, like especially on my team. It was very like kind of week to week with some long-term goals. So it wasn't a big deal for us.
Thank you.
Do you use Vagrant with Jenkins?
We do not, but to be fair, our build is very complicated. To give you an idea of how it looks right now, like we're evaluating a third-party service which lets us host. It's basically a build infrastructure that'll fan out on Amazon services, but we host the software ourselves, so it's in our private cloud, right? So we're evaluating this, which replaces Jenkins. It's a completely different thing, but it's got the idea of the distributed build, so it'll fan out into a bunch of smaller jobs and aggregate the results, right? And this is what we did at Discuss with Jenkins. But inside of Jenkins at Discuss, I know we did try to use Vagrant, but I think we eventually didn't, and I don't remember why. I think we still had VMs, but I don't remember how they worked. And we supplement all of this in our build system at Dropbox right now by running the exact same script to provision. So like Vagrant calls out to this like bash script, and that's the exact same thing we run on the CI server. And so that makes it like to where we're confident it probably works, and we don't really need to manage the machines because like there's like plugins for Jenkins that'll spin up EC2 machines for you, right? And then we have this other system that does it for us, so it's not a really big deal. And we're also looking to move towards containers as well, the LXC stuff. And I feel like Vagrant will be less important at that point unless there's some, maybe there's already some Docker support built into Vagrant, but it'll kind of change the scope of the problem.
Because I have found just fetching the dependencies every time I am building takes more than 20 seconds.
It takes about 30 minutes still for us, but we solve that by snapshotting. So our CI machine, and this is, You can do this however you want, but the idea is like every day or whatever, it's going to snapshot the last successful build, just like the provision phase. So it might actually rerun the provision phase to get a clean build, and it'll save that to like, say you're on EC2, it'll just save it to a disk snapshot, and then you can just reload that. That's actually, I think that's a really good way to solve it. And Vagrant, it's kind of the same idea. We're just going to rebuild the box every day. And we can do that with a CI, which actually is kind of like Inception a little bit. But yeah, that's our solution is like, we have all these dependencies. Like I listed some of them that are actually like plaguing me that I want to get rid of from our dev environment, but there's like 30 dependencies inside of the Dropbox virtual machine, and it's way too complicated and way too slow to set up. It's still like, we've got it down to 10 minutes to provision from our partial box, but the snapshotting phase is still like the best bet. Like speeding up provision is very, very hard.
Any other questions? We have 10 minutes more.
I talk very fast.
Yeah.
Hopefully everybody understood me.
So I'd like to close this session. Thank you very much.
Yep, thank you guys.
Sorry, I announced this is the last talk in this